I'm presenting Slipping Through the Cracks, how malicious emails evade detection. So first, who am I? My name is Elyssa Boulila. I'm a security researcher in the Global Security Operations Center of Amadeus. So for those of you who don't know, Amadeus is an IT company that provides software for the global travel and tourism industry. And my fields of expertise are email security and threat intelligence. The work that I will be presenting today is based on my current PhD research, and is also based on a European project called Rescue, Resilient Cloud for Europe. So, let's dive into the topic. Phishing is a perpetual cat and mouse chase. This field is heavily researched, yet phishing remains on the rise, both in frequency and impact. And although companies deploy advanced commercial security tools, gaps remain. And one of the reasons why is that evasion techniques are constantly emerging, allowing attackers to bypass even top-tier email security filters. So for the background, usually in companies, whenever there is an inbound message, it will first go through an email security layer, and depending on the verdict, that message will have different destinations. So if it's malicious or spam, it will be quarantined or it will not be delivered. But if it's safe or clean, it will reach the recipient's inbox, and eventually the user will read their message. In a few cases, the user might think that message is suspicious, and usually in companies today there is a policy where each employee is encouraged to report a message whenever they think it's suspicious. In that case, the reported message will be sent to the Security Operations Center, where a security analyst will read it, analyze it, and take further actions if necessary. So, about our study, we would like to assess the evasion techniques that are actively used today by threat actors to evade detection. And to do so, we had access to 10 months of email exchanges pertaining to 5 organizations with diverse business activities. And we rely on the user-reported messages that are confirmed as malicious by security experts. And this represents a rich data set of evasive phishing emails, because as I said, these are the messages that were able to evade all the detection layers in place, yet were identified by the recipients themselves and identified as malicious by the experts. The work that I'll be presenting today is based on a paper that I published recently. It's called A Closer Look at Modern Evasive Phishing Emails. So if you want to know more, you can read the paper or you can reach out directly to me. So, before I present the results that we obtained from running this study, I first have to present the taxonomy of the evasion techniques as we know them in the state of the art, and that will enable you to understand why we did things a certain way and not another, and that will enable you to understand better the results as well. So, evasion can happen at the message level, so with the use of obfuscation, the use of QR codes, or hidden text. It can also happen with clocking, which is a technique that conceals phishing pages from web crawlers while keeping them visible to human victims. So, let's say we have a phishing URL. If it's visited by the targeted victim, that client will reach the malicious content. So, typically, a page with a login form that tries to harvest the user's credentials. If that same URL is visited by a security scanner, so a bot, that client will reach a benign page. So, for example, a blank page. And obviously, if the security scanner is not able to see the malicious content, it's very hard to make the right verdict and confirm that page is phishing. And clocking can happen in 2 ways. The first one is at the client side. So, for example, when the page is loading, there will be some JavaScript running in the background, collecting information, trying to understand if the environment corresponds to a browser operated by a human or an automated tool. So that's what we call browser fingerprinting and bot detection. It can also happen at the server side. So, for example, if you have a phishing server, if it receives an HTTP request from an IP that is known to be associated with a data center or a security firm, that in that case, the phishing server will respond back with a benign content. But if the IP could be associated with a targeted victim, the phishing server will give back the malicious page. So, knowing this, we needed to develop our own analysis infrastructure that can bypass clocking and, more generally, the evasion techniques that threat actors use. And that's how we came up with CrawlerBox. It's our analysis infrastructure. We make it open source for anyone to use. So if you want to reproduce this measurement study, you can use CrawlerBox. And this is how it works. So typically it will take as an input the reported messages that are confirmed as malicious. It will extract the headers, and then it will parse recursively all the mail parts, so the body, the attachments, and so on. The URLs will be extracted, as well as any web resources, and that includes JavaScript and HTML. And all the web resources will be loaded in an automated browser instance, which we call not a bot, so it's our crawler component, but obviously it is a bot. And we will record the network traffic, so everything that goes to and from the browser, and that includes the requests, the responses, the domains, TLS certificates, HTML, JavaScript, CSS, images, and so on. We will enrich the collected data with external sources, and we will take a screenshot of the obtained page. Everything that we record will be later logged in a separate database. About the enrichment process, we use Whois information and Cisco Umbrella, and please keep in mind this because it will be important in a few slides. About Notabot, it's our crawler, so it's based on Puppeteer. The automation attributes are specifically hidden to evade bot detection. We also make sure that the network traffic is carefully intercepted to avoid peculiar caching behaviors. And we emulate mouse movements. So, I told you that phishing pages use clocking. So when we build Notabot, our browser, our crawler, we had 3 requirements in mind, and we made fingerprinting tests to make sure that Notabot is able to evade clocking. So the first requirement that we had in mind is passing basic bot detection tests, so passing BotD, which is an open source library for detecting basic bots. The second one is passing advanced JavaScript-based anti-bot challenges, so passing Cloudflare's turnstile. It looks like this. I'm sure you've seen it at least once. So basically what it does is there will be some JavaScript running in the background, collecting information about the browser, and the user needs to check a box to confirm they are human. And the third requirement is evading the detection of an advanced anti-bot commercial solution. For legal reasons, we refer to it here as anonymous WAF. We also wanted to compare Notabot with open source crawlers that are used in the security field. So we compared it with Kangaroo as part of Assembly Line, Lacus as part of the AIL framework, and Lookilo, I believe, Puppeteer and its extra stealth plugin, Selenium Stealth, and Undetected Chrome Driver. We also compared it with Node Driver and Selenium Driverless, even though these 2 tools were developed way after Notabot, and they were not discussed in any prior work, but for the sake of completeness, we included them in the study. And these are the results that we obtained. As you can see in the table, Notabot is able to pass all the requirements we had. So it passes BotD, turnstile, and anonymous WAF without even so it passes turnstile without even have to check on that box there. And for that, Cloudflare rewarded us with a bug bounty associated with a medium security vulnerability. As you can see also in the table, Notabot outperforms the majority of the crawlers, but Node Driver and Selenium Driverless perform as well as Notabot, but we don't consider this as a limitation. On the contrary, we recommend diversifying the crawler components within an analysis infrastructure because that could only be beneficial in studying sophisticated, stealthy phishing attacks. Okay, now about the results. Over 10 months, we used CrawlerBox to scan messages, so from January 24 to October 24, and we scanned more than 5,000 messages. And among these, 30% correspond to active phishing, so mainly phishing that redirect to a malicious login form. We also wanted to identify spear phishing. So remember I told you that we take screenshots of the obtained pages, so we use fuzzy hashes like phash and dhash and the Hamming distance to compare the obtained screenshots with the legitimate login pages of the organizations under study. And using this method, we confirmed with high confidence that 73% of these messages are actually spear phishing. But This needs to be interpreted carefully because there could be a bias in how users report a message. So, for example, if it mimics their organization, or there could be a bias in how security experts confirm a message as malicious. But anyways, the obtained dataset represents evasive messages that were able to evade detection, and we will use it to extract these evasion techniques. So we collect more than 1,400 distinct landing URLs corresponding to more than 500 distinct landing domains. And these are the TLDs that we obtain for the landing domains. So .com is in the first position without any surprise because it could be used to add legitimacy and for tricking users. We also see some cheap TLDs like .buzz, .xyz, .click, and so on. But .dev corresponds to subdomains of the workers.dev, and we also were surprised to see .ru in the second position. About the deployment timeline of spear phishing, there are 3 important dates. The first one is the landing domain registration date, the second one is the TLS certificate creation date, and the third one is the message delivery date. So we refer to as time delta A, the difference between the landing domain registration and the message delivery date, time delta B, between the TLS certificate creation date and the message delivery date. For these 2 variables, we notice fat tails distributions. So 102 domains have a time delta A over 90 days, only 5 domains have a time delta B over 90 days, the median time delta A is 24 days, and the medium time delta B is 8 days. We notice that we have 71 outlier domains, but only 20 of these correspond to legitimate compromised websites. So what you have to understand from all these numbers is that this is a particularly new behavior. In the state of the art, the landing domains are registered a few hours before launching an attack. But this is not true anymore, as you can see here. And from an attacker point of view, it actually makes sense because the age of a domain is a metric that is used to assess the suspiciousness of a domain. In particular, if a domain is younger than 90 days, it's giving a low reputation score. So, from an attacker point of view, they want to age their domain to evade these reputation-based filters. Okay, we also wanted to understand if we're facing small-scale attacks or large-scale ones. So we noticed that the average number of reported messages per landing domain is 2.62. The maximum is 58, and the median is 1. So we had a suspicion that we're facing majoritarily low-scale attacks, but a few are large-scale ones. But to confirm this suspicion, we use a Cisco umbrella. So for those of you who don't know, Cisco umbrella gives access to passive DNS logs recorded from DNS resolvers all around the world. And we used it to check the DNS query volume for these landing domains for the last 30 days preceding message delivery. And we noticed that we have small-scale campaigns because we have a low median total query volume. So it's 43 for the domains that are associated with only one message, and it's 100.5 for the domains that are associated with multiple messages. And this suggests a shift toward low-profile, high-impact campaigns. We also noticed that we have a few large-scale campaigns because the domains that are associated with the most reported messages have by far the highest DNS query volume, and this indicates broad high-volume attacks. So I'm very aware that DNS resolvers have caching mechanisms, and these are lower bound estimates. However, as you can see, there are differences in the orders of magnitudes, and this confirms small-scale versus large-scale attacks. About the evasion techniques, for time constraints, I will not be able to present everything, but I will try to present to you the most interesting evasion techniques and the newest ones. So the first one is that we identified a bug in QR code scanners employed by email filters. This it uses faulty QR codes whose decoding generates a syntactically incorrect URL. So it's built like this. The data inside will be some irrelevant characters followed by the phishing URL. So these are a few examples. So xxx space https elyssa.com, given that xxx could be any collection of ASCII characters. Or it could be bracket https elyssa.com. So I put here an example. The QR code contains DSN space https://google.com. If you scan it with your phone, you'll be prompted to visit google.com. So your camera is able to ignore the noise within the QR code. But this was not true for email filters. They were not able to extract the URL within a syntactically incorrect QR code. And that left users and that this mismatch left users vulnerable to QR code-based attacks. Well, this attack is very, very simple, but it is smart because usually employees scan a QR code with their personal phone. And these phones fall outside the perimeter of the corporate security defenses. The second evasion technique, well, I didn't include it in the paper, but I included it in the presentation because I thought it might be of interest to the audience, is the use of malicious SVG attachments. So we received those from July 24 to May 25, and we received a little more than 45 reported messages, so very few relatively. And so if you don't know, SVGs are scalpel vector graphics. They are images, but in reality they are XML files that happen to contain JavaScript, possibly. They are opened by default by the browser, and the browser executes the JavaScript inside automatically. So you see where the problem is there. And I put an example that was received in March 25. So it looks like this. It's an SVG that is an XML that contains JavaScript. It's obfuscated, but it's very simple. Basically, there is an XOR function that will decode a string given a key, and that decoded string will be loaded within the browser. What catches the attention is the use of these weird comments. They don't make any sense, but we think that they are included within the script to a full AI-based or text-based detection. We also see this weird variable here. It's redacted, but it used to contain the email of the targeted employee. I also put another example from May 2025, so it's a couple of months later. It's a little bit more complex, but at the end very simple. It looks like this. So same thing, XML that contains JavaScript. There will be some declarations at first. So this tracker data variable will be declared, but then randomized, so doesn't make sense. And then there will be these weird functions that are created for noise, so they don't have any functionality in the attack per se. But what also catches attention is how well documented this code is, with the comments, readable functions, and so on. So we think that this code might be generated by an LLM. Also, this code will have an encryption function later, and a decryption one. So it takes as an input the encrypted data. It will decode it with a passphrase, which is fun. It has the salt value, the IV, and so on. And then it will actually decode the string after a delay, so after 600 milliseconds. And this is what we call a delayed attack. And if you don't know, I think many of security scanners or filters don't want to wait until making a verdict for usability reasons because they want to deliver the message as fast as possible. So they don't wait enough, and that's apparently threat actors know about that, so they delay their attacks by a few milliseconds, just enough to evade detection. And this is a decrypted string, so it's very simple. It will load this phishing URL within the browser, basically. About the clocking techniques, we noticed some clocking techniques relying on user interaction. So, for example, the user needs to input an OTP that is sent in a separate message to access the phishing login page. There could be some custom challenge response authentication, so custom CAPTCHA-like checks. There are some bug detection attempts, so relying on debugger detection, relying on filtering based on JavaScript attributes, so attributes within your browser. For example, the navigator.webdriver value, navigator.useragent, navigator.language, and the time zone. We also noticed that a staggering 3/4 of the identified phishing pages are protected by Cloudflare's turnstile. So you see why it was important for us to have a crawler that is able to bypass this tool. We also see some fingerprinting attempts, basically relying on the abuse of legitimate fingerprinting libraries, mainly BotG and FingerprintJS. And these attacks were associated with only 5 messages received from July 9th to July 18th. So it was a very punctual attack. We also see some server-side filtering. So obviously we don't have access to phishing servers. However, we found scripts that try to exfiltrate the client's information enriched with third-party services. So the exfiltrated data contained the IP, the country, the city, the ASN, the network provider, and so on. And we also saw many attempts at victim tracking. About the takeaways, these are smart attacks. There is a shift toward low-profile, high-impact campaigns. The rise of relatively new trends of implementing new techniques in non-cloaking categories. The attackers leverage advances in the browser fingerprinting and bot detection fields. And we think that our findings are generalizable and transferable to other institutions. For the 2 reasons is that there is a high degree of source code reuse among phishing kits, and there is a proliferation of phishing as a service platforms. In 2026, we plan to share the obtained CTI with partners via MISP. So if you're interested, you can reach out to me later. So, like I said, these are smart attacks, but we need to have smarter defenses. So we provide CrawlerBox as an open source tool and analysis infrastructure if you want to reproduce this measurement study or use subparts or submodules of this tool. We also recommend to adapt defensive mechanisms, especially we recommend to have web security scanners that exhibit a fingerprint that is consistent with browsers operated by humans. But we acknowledge that the main implementation issues are cost and scalability. And that's it. Thank you for your attention.
Wow. So Cloudflare protects almost 75% of all phishing pages.
Yeah,
so they're really
reported
defenders of the internet, huh?
Exactly.
Woo. All right, questions?
Thank you very much for the presentation. Really interesting. I was just wondering, for the mouse movement emulation, did you do it at random? Because I remember, I think it was Luma Stealer, a malware that, as an anti-sandbox measure, was looking at mouse movement to see if it was kind of realistic. Did you need to do that at one point to bypass the anti-bot, or not at all?
So I thought like you, I thought that I had to have really realistic mouse movements, randomized, but not that randomized because it would be obvious to detect them. But at the end, looking at the scripts that are loaded by those phishing pages, they didn't check that much. They just check if the mouse moves. And I think there are some libraries that are specifically made to generate these mouse movements. So in the future, if we need to change this, I think it would be possible to do it.
Thank you.
Thank you very much. Thank you for the talk. I want to clarify one slide you had. It was quite quick. I didn't get it. It was about most used phishing domains. It was Russia in number 2. Is that correct?
It is.
And could you maybe say a few words? So does it mean the most second most used phishing domain sites worldwide come from Russia? That's what it means.
It is. But let me go back to the slide. I mean, there are a lot of slides there.
It's okay. That's answer.
Yeah, I think it will be this one. Yeah. So yeah, it's in the second position, but actually Russian registrars might offer some advantages to fishers. For example, easier to register domains or cheaper ones. I mean, their policies change a lot, and that's why maybe fishers use this TLD to have phishing domains.
Thank you very much.
I am not seeing any further hands. Thank you, Elyssa.
You're welcome.